Today we're going to learn how to solve systems of equations using the substitution method. So when you're wondering what type of method to use, the substitution method is going to be best when you have a system of equations where one of your equations has a variable that has a coefficient of 1, or a variable that's already by itself on one side of the equation. Or if you don't have either of those, you may sometimes have an equation that even though you don't have a coefficient of 1 and you don't have a variable by itself, you can easily manipulate your equation so that you do get a variable by itself. So let's look at some examples of some equations that would be best solved by substitution. In this example, you'll notice that y is by itself. Because I already have y by itself in one of my equations, I know that substitution is going to be a good method to use to solve this system. In this system of equations, neither of my equations have a variable by itself. But if I look at my first equation, my x has a coefficient of 1. There's nothing in front of that x, which means I know there's an invisible 1. So what I would do would be to get x by itself, and to do that, I would add y on both sides of this equation. And if I did that, these would cancel and leave me with x equals, and on this side, I would have y plus 1. So now I would have x by itself on this side of the equation, which means I can easily use the substitution method to solve this. So, when we're solving a system by substitution, the very first step is what I just showed you. You are always going to solve one of the equations for one of its variables. And what we mean by that is you either get x or y by itself. So in this system, I got this equation, well, it was already given to me this way, but y is by itself. In this equation, I had to change the equation so that x was by itself. Now, once I do that, then the substitution part comes in. I will substitute the expression that's found into the other equation. I will solve that equation. And when I solve that equation, that will either give me an x value or a y value. But remember that the solution to a system of equations is always an ordered pair. So you always would have to find both x and y. So once you have solved for either x or y in step 3, step 4 is going to be to go back to your original equation and plug in what you just found for x or y to find the other variable. Once you're done with that, you will write your answer as an ordered pair and make sure you have x first, y second. And always go back, especially with the substitution method, because it's easy to make a mistake somewhere. Check your answer. And you are going to check your answer by plugging your x and y values into your original equations, both of them, to make sure that they are correct. So let's look at some examples. This system says 2x minus 5y equals 22, and x plus 5y equals negative 4. If we go back to what our step said, our first step was solve for one of your variables, which meant to get x or y by itself. Now, this equation, my first equation, does not have an x or y by itself, and neither does my second equation. But when I'm looking at them, one of these would be easiest to change. And I noticed that in this second equation, I have an x that has an invisible coefficient of 1, which means this is the equation that I should use to get a variable by itself. And the variable that I'm going to get by itself here is going to be x. So that's what I'm going to start with, is my x plus 5y equals negative 4. I'm going to change this equation so that x is by itself. To do that, I'm going to subtract 5y from both sides of the equation. These will cancel and leave me with x equals, and then I have negative 4 minus 5y, or that's the same as saying negative 5y minus 4. And you could write it either way for this. Now, step 2. Step 2 is the part where you really want to pay attention. Step 2 is where the substitution parts comes in. You are going to substitute the expression you found into the other equation. What that means is that I started with this equation, which means for step 2, I'm actually going to use the other equation. So my other equation was 2x minus 5y equals 22. When it says substitute the expression found, that's the expression that I found in my first step. This means in my first step, I found that x is equal to negative 5y minus 4. If I'm solving an equation, I can only solve for one variable. But in this equation, I have two variables, which means I want to manipulate the equation so that I'm only solving for either x or y. What I can do is I can take what I found here, which is that x is equal to negative 5y minus 4, and in my other equation, I can take out the x and I can replace it with negative 5y minus 4 because I know that they are equivalent. So I would write this as, instead of 2 times x, it would be 2 times negative 5y minus 4. Again, because that is what x is equal to. Now that only gets me to this part, the 2x. Then I have to rewrite the rest of the equation, which is minus 5y equals 22. So now I have substituted my x into my other variable, or my other equation, and now I need to find out what the value of y is. So step 3 is to solve this equation that we wrote in step 2. Well, if I'm solving this equation, I know that the first thing I'm going to need to do is use the distributive property. So I'm going to distribute 2 into my parentheses. So 2 times negative 5y is negative 10y. 2 times, this isn't 4, it's a negative 4. So it's 2 times negative 4 is negative 8. So I would write minus 8. And then the rest of my equation, I still have minus 5y equals 22. Now, I remember that if I'm going to solve an equation, I need to combine all of my like terms. So on this side, I have negative 10y minus 5y. I need to combine those because they are like terms. So if I do negative 10y minus 5y, that gives me negative 15y. But I would still have minus 8 equals 22. Now I'm just going to solve this like I solve any equation by using inverse operations. So I will add 8 on both sides. Those would cancel and leave me with negative 15y equals 22 plus 8 is 30. Now to get y by itself, I'm going to divide by negative 15 on both sides. Those would cancel and it would leave me with y equals, and positive 30 divided by negative 15 is negative 2. So I found that my y value for my system of equations is negative 2, but I also need to find my x value. So step 4 is substitute the number. So substitute negative 2 into my first equation to find the value of the second variable. So let's go back to what we did in step 1. In step 1, we wrote this equation, x equals negative 5y minus 4. Well, let's plug in negative 2 for y because now I know what y equals. So to find x, I'm going to do negative 5 times y, but I just found that y is equal to negative 2, and then it's minus 4. Negative 5 times negative 2 is positive 10, and then it's 10 minus 4. If I do 10 minus 4, I get x equals 6. So now I know that my x value is 6, my y value is negative 2. Step 5 is to just write your answer as an ordered pair. Remember, an ordered pair is always written in parentheses, x value first, followed by a comma, y value second, and then you close your parentheses. Let's look at another example. This one says y equals negative 4 and negative 3x minus 6y equals 15. So step 1 says solve one of the equations for a variable, which means get x or y by itself. But what I notice is that in my first equation, I already have y by itself. So I'm going to use this equation, which is y equals -4. Step 2 says to substitute what I found for y into my other equation. So my other equation was -3x minus 6y equals 15. I am going to plug in -4 for y in this equation. So this is -3x minus 6 times y, but y is equal to -4, so 6 times -4, and it equals 15. Step 3, now that I have substituted my -4 in, is to solve my equation. So first thing I'm going to do is -6, and you've got to really be careful here because this is not a 6, this is a -6. -6 times -4 is positive 24. So -3x didn't have a like term, so I'm leaving it the way it is. -6 times -4 was positive 24, so I would write plus 24. And then that equals 15. Now I'm going to solve like normal, so I will subtract 24 from both sides of my equation. These are going to cancel and leave me with -3x. And if I do 15 minus 24, I get -9. Now I still need to get x by itself, so I'm going to divide by -3 on both sides. Those would cancel and leave me with x equals, and -9 divided by -3 is positive 3. So x has a value of positive 3. 4 says to substitute the number that you found in step 3 for the variable in the first equation. The problem with this is that in this case, my first equation just said that y equals -4. If you remember when we were graphing, that just means that I'm going to have a horizontal line where everywhere on the line y is equal to -4. So there's nothing that I can actually plug into this equation. This is just telling me already that the value of y is -4. So my answer is going to be written as an ordered pair where x is 3, followed by a comma, y is -4. Let's look at our next problem. Y equals 2x plus 4 and y equals -7x plus 4. What you'll notice about this is that in both of these, my y values are already by themselves. So I could choose either of these for step 1. So if I just choose my first equation for step 1, then I'm going to use y equals 2x plus 4. My y is already by itself, so I don't actually have to do anything for this step. Step 2 says substitute this expression, so I'm going to substitute this 2x plus 4 in for y in the other equation. Well, the other equation says y equals -7x plus 4. So what that means is I'm going to replace the y with the 2x plus 4. So instead of y, I'm going to write 2x plus 4, and then it equals -7x plus 4. Now step 3 is solve the equation. If I'm solving this equation, I know that I need to get all of my variables over to one side. So the easiest thing to do here is going to be to get rid of my -7x by adding 7x on both sides. If I do that, 2x plus 7x gives me 9x. I didn't do anything with this plus 4, so I'm going to rewrite it as plus 4. -7x plus positive 7x will cancel, and I'm left with positive 4. Now I'm just going to solve like normal, so I'm going to subtract 4 from both sides of this equation. 4 minus 4, it will cancel, and I'm left with 9x equals 4 minus 4 on this side is 0. Now, x is still not by itself, so I would divide by 9 on both sides. These would cancel, and I would be left with x equals 0 divided by 9, which is 0. Now that I know that x is equal to 0, step 4 is going to be to substitute that in for my first equation. So we're going back to this equation that we wrote down on step 1. So that equation said y equals 2x plus 4. I'm going to substitute 0 in for x to find my y value. This says 2 times x, so I'm going to do 2 times 0 plus 4. 2 times 0 is 0, so it's 0 plus 4. And if I do 0 plus 4, that means that y equals 4. So now that I know both x and y, I write my solution as an ordered pair. X is 0, y is 4. All right, for this one, y equals 2x plus 9 and 5x minus 3y equals negative 30. I can see that my first equation already has a variable by itself, so that is what I'm going to use. Now I'm going to substitute this 2x plus 9 in for y in my second equation. So my second equation said 5x minus 3y equals negative 30. Instead of y, I'm going to replace that with 2x plus 9. So I'll rewrite it so that it's 5x, and then it's minus 3 times y. But again, y is 2x plus 9 because that's what I'm replacing it with. And then all of this equals negative 30. Step 3, solve this equation. The first thing I would do to solve this equation would be to distribute my negative 3 into my parentheses. Again, remember that's not a 3, that's a negative 3. So we have 5x on the outside, the negative 3 times positive 2x, and that is negative 6x. The negative 3 times positive 9, that is negative 27. And all of this is equal to negative 30. Now I'm going to combine my like terms, and on the left side of my equation, I have 5x minus 6x, which is negative 1x, or that's the same as just saying negative x. And then I have minus 27 equals negative 30. Now to get x by itself, I'm going to add 27 on both sides of the equation. These are going to cancel and leave me with negative x equals negative 30 plus positive 27 is negative 3. Now, x is still not by itself because there's actually a coefficient of negative 1 here. So I'm going to divide by negative 1 on both sides to get x by itself. When I do that, I get x equals, and negative 3 divided by negative 1 is positive 3. So x equals positive 3. Now that I found x, I need to find the value of y. So I'm going to take this and plug it into my very first equation. So my first equation was y equals 2x plus 9. But I found that x is equal to 3. So y equals 2 times 3 plus 9. 2 times 3 is 6. So y is equal to 6 plus 9, which means that y equals 15. So now that I know my x value and my y value, I'm going to write it as an ordered pair where x is 3 and y is 15. Right now for this problem, again, we have a problem where we have two equations that have your variable by itself. So you can just choose one of them and it doesn't matter which one. I'm going to choose the first one just to make it easier. So this one is y equals 4x minus 8. The variable is already by itself, so I don't have to do any extra work with that. And what I'm going to do is substitute 4x minus 8 in for y in the second equation. So I'm going to write my second equation, which says y equals negative 4x plus 24. And I'm going to replace the y with 4x minus 8. So it's 4x minus 8 in for my y equals negative 4x plus 24. Now I'm just going to solve my equation. So I know if I were solving this equation, I would get all of my variables over to one side. So I can get rid of my negative 4x by adding 4x to both sides of this equation. And if I do that, 4x plus 4x is going to give me 8x. I still have minus 8 that I haven't done anything to, so I have to rewrite it. On this side of my equation, negative 4x plus positive 4x will cancel and leaves me with positive 24. Then I'm going to add 8 on both sides of my equation. Negative 8 plus 8 cancels and leaves me with 8x equals 24 plus 8 is 32. Next, I'm going to divide by 8 on both sides, and these will cancel, and I'm left with x by itself, and 32 divided by 8 is 4. So x is equal to 4. Now that I know that x equals 4, I'm going back into my original equation, which said y equals 4x minus 8, and I'm going to substitute 4 in for my x value. So y equals 4 times x, but in this case it's going to be 4 times 4 minus 8. 4 times 4 is 16, so y is equal to 16 minus 8, which means that y equals 8. So my solution for this system of equations is an x value of 4 and a y value of 8.